This discussion is about electric circuits. We find this on page 3 of our notes, Roman numerals 8 and 9. Going to the slideshow, we're going to start at slide number 36. A circuit is a closed conducting pathway for electrons to flow through. There must be a complete pathway for electrons to flow through. So I'm going to start with the image on the right, the open circuit. Notice that the wire on the bottom is not connected to the light bulb. And because of that, electricity or electrons cannot get through the circuit. It opens up the circuit and the light bulb is not lit. But here on the left, that wire is connected. And so there are three things that we need to have an electric circuit. We need a source of electricity, which in this case is a battery. It doesn't have to be a battery, but in this case it is. We need wires, which are conductors. Once again, it could be like on a circuit board. You might not have wires. You might have other conducting pathways, but typically there are wires. And then you need a load. In this case, it's drawn as a light bulb. That load could be some other type of resistor or a motor or some other electrical device. But the three minimum things that you need to have in an electric circuit, you need a source of electricity, you need a conductors, and you need a load. And when those things are connected in a closed pathway, electrons are able to flow as indicated here. Now, I do want to point out there's two different ways to show the direction of electricity. And that is, sometimes we show it from positive to negative, and sometimes we show it from negative to positive. We don't want to get hung up on that as far as that pathway goes. The conventional way is to show it as it shows here from positive to negative, but in reality, the electrons are negative and it goes from the negative to the positive. We'll see it both ways. So a simple circuit has those three things I talked about. A source of electricity, which is the battery, could be a generator. Conductors, which are usually wires. A load, which is what the electrons do the work on. A light bulb or motor. Now, you can go back and watch this video here. If you're in the present mode, you can watch that video. I believe we also put it on the agenda. The flow of electrons in a circuit can be compared to the flow of water in a system. So here we have a water pump, and the water pump is pushing water up on the right side, and that creates a high pressure zone. And the water that's going back into the pump is the lower pressure zone. So we have a little circuit where this water is flowing around, and as it's flowing around, it's turning this water wheel. It's doing work on something. Okay, the same thing is true where the pump gives the water pressure. Well, in this case, the battery is giving the electricity or the electrons pressure or a push, and it's pushing those. And you see the areas of high voltage and low voltage. Voltage is the pushing electrons, which is causing this fan to spin. Slide 38. We will see there's a number of drawings. And in your notes, there is a section here for some drawings. Letter C, drawing below. And so we're going to recreate this chart into our notes. To do so, I'm going to go here to PowerPoint where I can do some drawing. And let's start with a battery. A battery has two parallel lines. One is longer, one is shorter. And then these lines that come off of it are the wires that we would connect to the system. All right. Sometimes we will see it drawn with like this. And you will have the positive and the negative. So there are limits to what I'm drawing on the computer screen. But sometimes we will see this second line here be a little bit thicker. And let's see here. In this image right here, you see that this line here is just a little bit thicker than what that line is. It's a little bit hard for me to do that on the particular screen that I have, the way I'm drawing with my finger on the PowerPoint screen here in order to do this. So once again, that was the battery. Let me see if I can draw it with the mouse. like this. Okay, and we can stack batteries. Sometimes we stack 2, sometimes we stack 3, depending on what the circumstance is. And this is the positive side, this is the negative side. Now keep in mind that the longer line is the positive side, the shorter line is the negative side. So you don't have to label it positive, negative, but it never hurts. Now a bulb, actually I'm going to come down here to the resistor. A resistor looks like this. Okay, so when we see that, we can kind of put like a glass bulb around that to make a light bulb, but we will see that a bulb, you just kind of make a loop like that with a circle around it. That's your bulb. And notice that you got the wires on the left and right coming out of it. We'll also see some drawings where a bulb looks like a big X. A motor, we just draw an M, put a circle around it, and draw our wires that are coming out of it. I'm going to come over here to the voltmeter. Keeping with that theme, we draw a V for the voltmeter, draw a circle around it, have our wires coming out of it. An ammeter, same thing. Start with an A, extend it like this. Now, a switch, we're going to have the connection point of the switch right here and here. And so the wires are coming to the left and to the right. And then the switch, because this is an open switch, is going to be open like this. Notice that it does not connect. A switch closed, once again, we're going to have those connection points with the wires to the left and right. But because the switch is going to be closed, it's going to go over here and close just like that. Now those connection points, we're going to draw those again with the fuse. So I have that little circle with the connection points just like that. And now I'm going to draw like a sideways S as my fuse. And then a wire is just a line like this. So these drawings, you are going to put into your notes. They're following the drawings that are on the slide. Let's see here. We want to. And what we will do is we're going to use these drawings in order to put them together. So let's say we wanted to draw a battery. And then we're going to connect that to a light bulb. When we draw these, I like to draw rectangular lines. In other words, nice straight lines that keep it nice and neat and clean. This right here is a basic simple circuit. Now, these lines here should be connected. I can see that I did not connect them to the best. So we want to make sure, pay attention that we draw them to the best. My finger on the screen kind of limits that, but when you're drawing it with a pen and paper, you can do it a little bit more accurately. Now, from that, I could recreate that drawing, but how about this time I throw in an open switch? So I'm going to draw a battery. Here's my open switch. I could also draw it with a closed switch. And we can add other devices to these particular things. But the lesson today is on simple circuits. And simple circuits, we're just looking at the 3 basic items that we need. We need to have a source of electricity, which is our battery, which I have right here. We need the wires, which we see there, and we need the load, which is right there. That is our simple circuit. So again, you'll want to take these drawings here and put those into your notes.